the main reason that we asked Dan to speak to this group, because you're not munis and co-ops, and as Dale and I talked about several times, the grid edge. You people use power to make things or process things or do things. They make power to sell you power. So their business is power, and your business is using power. And that's a huge differential. But here's the thing. His industry is ahead of the game in terms of some of these new technologies and adaptations. And when solid state, as you saw yesterday, there's just a lot of change in materials, in microtechnology, nanotechnology, and a lot of that comes into the utility world first. So they make the mistakes, they adapt it, they understand it, and then we get the benefit of having the entire utility world learn first. Dan is a husband and a father, a retiredee. I hate that. He's like he's 15, and he's retired already. But one of the other things about Dan, he is a tremendous leader. I've seen that. We've been over to Austin Energy a good bit. A great friend to not just SD Myers, but to this industry. And he is one of our advisory board members. He is the professional on the advisory board that you see up there. I don't know if you know that we called you that. Yeah, we called you the professional.
I've never been a professional before.
Or there you go. All right. But Dan Smith.
Thank you. Well, yeah, I guess the first shocker to me, I am the one person that's less than 100 miles. I do live here in Austin. I will tell you a couple of things real quickly. One, even though I'm from Texas, born and raised, I can talk very fast. And often when I stand up here, that's what happens. And so I do warn you. I also like to do things more in a Socratic method. I mean, in fact, this size of a room allows it to be a little interactive, so I probably will ask and pose a few questions, and I welcome the input, because quite honestly, my prayer and wish every time I stand up is that it somehow conveys or inspires and connects something that's of value to you, to what you need to do in your industry and your company. So please help make that happen. Another thing, full disclosure, isn't, in all that you stated, which was largely false, I went to Texas A&M University, and if you know anything about the state of Texas, A&M and UT are huge rivals. We continue to butt heads, but I got to confess something to you. I love this facility. This is a great place, and I've spoken here a number of times, and I always enjoy coming to conferences here, so I have to give credit to UT in regard to the facility and all. So those are a couple of quick things that I'll say up front. The other thing I really appreciated, Alan, you leading off with a safety moment. I am passionate about safety. It's ingrained in my DNA. I trust it's in yours as well, and it needs to be, because quite honestly, I believe that's what transforms our culture in a company. In fact, when you think about our most valuable asset being our people, there's no greater way that you actually exemplify that value in how you treat your people from a safety perspective. And it's not just lip service. I mean, you got to live it out in everything, anything that your company is about and doing. And as you do that, quite honestly, that's how you're successful in providing value to your customers, how you provide reliable services in whatever it is you're doing, the products that you deliver and all. So I am going to lead off with my own safety moment for a moment. How many of you are familiar with APS in Phoenix and even know about this incident? Chuck knows a little bit. Yeah, this is kind of an interesting situation. So I decided to take a piece of technology, lithium-ion batteries. Those things are growing in its use. Everybody knows. In fact, you see these things in automobiles. You see these in our cell phones. If you vape, I don't recommend vaping, but if you do vape and all, even those e-cigs have lithium-ion batteries. But they're also being used in these type of applications for stationary battery situations in substations, in larger facilities and even smaller ones. This is an interesting situation that happened, and I don't know how many of you are aware of it, but APS, Arizona Power Public Service, excuse me, they have a battery that's being used largely for integrating solar into their system. On Friday, April 19th, 2019, approximately 5 p.m., they had a fire in this storage. If you know anything about lithium-ion batteries, they basically have the ability to sometimes have thermal runaway. And so, by the way, they're still investigating what happened here, so I'm not going to give you a lot of the root causes of what happened. But I am going to state that what happened, first responders came, APS responded themselves, after that initial fire at approximately 8 p.m., a secondary fire occurred and actually injured 9 first responders. That's what makes this one a little interesting. Now, lithium-ion batteries, both in many applications, aren't having fires is not a new phenomenon. In fact, that's happened some. But this is the first time that we had people injured from that. And it was a pretty sobering deal because 9 people were injured. 4 of them spent time in the hospital. 1 spent several weeks and was recently released and all, thankfully and all. That person was actually blown about 50 feet back. So the percussion of when this enclosure was opened, basically pushed that guy back. He had a lot of internal injuries, had some burns, those type of things. Now the reason I bring this up is and you may not know this, is on some of these large-scale lithium-ion battery installations, Korea's had 26 of them in about an 18-month period of time. Did you know that?
26 fires?
26 stationary fires like this, systems like this, large-scale lithium-ion batteries. We weren't aware of that. By the way, we have 2 battery systems, this type of substation class systems in our, and so I want to tell you what we did, and I got to credit my program manager, Lisa Martin. She took in all this information. We had known about a few fires in Korea, but we weren't totally aware. But as we unpeeled this onion, we decided to take our system offline. And we decided the right thing to do at this point is to step back and reassess and look to see, are we doing everything that we can do to protect not only our personnel, but the first responders and certainly the public at large. So this is a significant event. Now, I bring it up because as we do innovate and the future is coming, not everything is totally tested and proven, right? In fact, there's tons of examples of this that we have in our industry. And there's a lot, I've got people, stakeholders in Austin that are saying, we want you to put 100 megawatts of this battery storage in. It is the savior. Once we put this 100 megawatts of battery storage in, we'll be able to get rid of every fossil fuel plant that ever existed. It's a great thought. However, we're really not there on the maturity curve. And that's probably one of the things to bring up. And I can't tell you how passionate I am, once again, about safety, because we can't innovate at the compromise of safety for certainly our personnel, but first responders and the public. So interesting story. Keep that in the back of your head and all. And we are going to go the manual route. So just a bit about Austin Energy. I won't spend a lot. By the way, we're called, we probably self-proclaim this, but we're called the live music capital of the world. We have over 250 venues that you can go out and listen to live music. Anybody caught live music since all of you are out of town here? Nobody? Okay. It's okay. It's all right. I know you spend time reading the book, right, and all that when you're. But but it's a great city to listen to music. Great city to try food and those type of things. But is it working? Am I just hitting am I probably hitting the wrong button, huh? Okay. Thank you. There we go. Okay. Just a brief bit about Austin Energy. We were founded in 1895, and we're the 8th largest public power company in the United States. We're managed, and our board is effectively the city council, which was a very interesting proposition, and I could talk a lot just about that alone. And to be honest with you, when I announced my retirement, some people said, "Oh, you were just tired of dealing with council." Actually, that's not true. I really did enjoy engaging them, but they were very. They did know a lot about the electric utility industry, and they pushed us quite a bit in some areas that, quite honestly, I don't think would have been consistent with reliability. But that's a point to be stated. About 1,700 employees, $1.4 billion budget. Our service territory is unique because we serve communities outside of Austin, but as I stated, we're run by the city council. They don't get to vote in the election. That kind of brings in a whole different type of proposition as we end up working with our community at large. We actually just recently eclipsed 500,000 meters. By the way, that's not the number of customers. A lot of times that's the way people refer to it, but the reality is we have lots of customers that don't have a meter, and I think that's the right way to look at things. We're vertically integrated, but the wholesale market, wholesale generation, the supply of energy in the state of Texas has been deregulated for some time. And so that's a place where it's totally competitive, which basically means even though we have generation, we bid that stuff in the market every single day. It's got to be profitable or it's not something we bid into the market. And that shows you where our peak and winter. We actually are starting to be a growing winter peaking thing. There's a lot of electric heat out in the west part of our service territory. There's a lot of rock and all. Our vision, this is interesting. This anybody know what year this was? This is downtown Austin. I know you're not from here, so I can just pop these things. You don't have any idea what he's talking about. 1997, you know, and then this is just for reference, 20 years later, this is downtown Austin. So Austin clearly has not really seen any form of a downturn. It's really interesting and a lot of fun, but quite honestly, big challenges because my head count to serve customers hasn't really changed either. So we've continued to grow. We do a lot of pretty interesting stuff to serve the downtown area, and some of you are, you know, in the midst of it when you're here visiting, but it's really, really a fun thing to deal with. This is just our mission visions and things with transmission. I'm going to kind of fly through this because I think the more important part is talking about reliability. Talking about reliability, there's something that Public Power rates utilities. You have to go through a kind of extensive interview application process. It's called RP3. We were the first public power company to actually receive that. We also became ISO certified. If I have time to tell a story, I'll tell you how that happened. But we were the first T&D, transmission distribution company within the United States to become ISO certified. Many of you, which I'm assuming, I didn't ask this question, but how many of you are kind of come from the plant reliability side? Got there. Good number of you. Okay, so I came from that, by the way. I used to work for Advanced Micro Devices, AMD, semiconductor manufacturer, and that's really kind of how I got raised and all. So I do feel I come from you, and I want to talk a little bit about that. In fact, let me ask you a question. What do you think, coming from that background, some of you plant operators going to the utility, what's one of the most stark differences in the system from a reliability perspective? What's that? What's that? Okay, yeah, there is a lot of institutional knowledge, and one thing utilities have the ability to really grab out to a lot of other utilities. Sometimes I found it challenging in the semiconductor industry. We kind of formed our own little niche and all. So we spent some collaboration amongst ourselves and all, but we often didn't spend time with paper mills, or we didn't spend time with the steel or Alcoa or whoever else, right? But so there's some interesting aspects about that. There's one thing I noticed different. I will tell you, I walked out of my AMD office right into the plant, and I always had my facilities right there, right? My issues were always right there. Electric utility industry, you've got miles and miles, hundreds, in some cases thousands of miles. Your infrastructure is in people's backyard. It is all over the place. I promise you, I miss being in the semiconductor industry in that case. I mean, that is really the case. I mean, it was nice to have it sort of confined to where I could really focus my energies. This is a challenging aspect of what electric utilities deal with. But this kind of gives you a little bit of picture of what our snapshot of it. And once again, the one thing that's mainly different here that I'd like to talk a second about. So I worked with my public involvement people to actually generate this infographic. If you don't like it, it's their fault. If you like it, I created it. But this is kind of the main thing that was different is I said, we continue to show things as a one-way flow of power, basically coming from a supply power plant going through transmission, distribution, substations, and then into the customer load. But the reality is our customers are starting to generate now. And so it's become a two-way flow of power and information, and that's really a tremendous future that we're walking into, and we're happening, and we're seeing it now. But it's also posing a lot of challenges now because we didn't build the transmission distribution system to operate that way. The customer. So really, kind of interesting. We cannot talk about reliability without recognizing that really it ultimately is about the customer. And certainly from a utility perspective, sometimes in the plant, I think I continue to have to recognize that in my case, the process, the fabrication facility, that was my customer, right? And I had to really treat them like that. But the customer is where it really matters and all. And I'd ask you this question. I mean, basically today, who's defining the customer experience? What's that? The customer is, that's right, okay. And when you think of people that are actually doing customer experience well, who do you think of? Apple, yeah, right? Who else? Tesla, all right. Amazon. All right, you know what's really good about this is so far, all three of those icons I put up there, I got their logos, right? But you could put, that's great. I mean, I'm glad we're connecting, but this is the reality, right, is they're the ones defining the customer experience now. So this is for all of us. I mean, when I look at what I do in the utility space, I mean, it's not, hey, you're better than Pedernales Electric. They're a co-op here, by the way. Nobody here's from Pedernales, right? In fact, I only answered the survey, so I'm the only one local here. But no, they're not comparing us to another utility. They're saying, no, why can't I go onto my phone and do everything I want? Pay my bills, know what the status is of my power outage, whatever it might be. I don't want to have to call somebody or whatever that might look like. So they're defining the customer experience, right? And that's and the interesting thing about this is probably Amazon's one of the main ones that define it, get it now type space, but right, they're the standard as it stands right now. It might not be that way tomorrow. I think that's a really interesting thing to comprehend and connect, but also recognize there's a lot of disruption with this. So, I mean, Tesla clearly has a vision, and quite honestly, so does even Google, of what they can do in the energy space, what they could actually provide. We all heard about the 100 megawatt in 100-day battery solution from Tesla. The thought is that's meant to be a very disruptive element of what could be done in the electric industry. So the reality is, and I've said this numerous times, some people have heard me say it, is the reality is we have to partner, we have to recognize that the business model's changing. And I'll talk briefly about that in a moment. Our utility customer evolution is starting to look like this. And just to give you a picture with some of this stuff, some of you may have these Nest thermostats. They're wonderful. I've got 2 of them, though my wife wants to rip them out the wall and stuff. She asked me that the other day, because we had one of these events, very hot summer day here in Austin, and we send a signal to these thermostats to set back the temperature or raise the temperature to do a demand response. And we do that. And we effectively have attained about 50 megawatts just by doing thermostat control in the city. That's roughly a peaking generation unit. That's what that is. So we're able to avoid turning on a peaking generation based on that 50 megawatts that we gain. So these things are great. And my wife's problem is that, yeah, but I'm getting hot, type deal. So I get that. But quite honestly, it's a short event. We do these things for 30 minutes at most or so. This is a home energy management system. Customers are doing things now where they're able to look on their phone and really understand what their usage is. In fact, they've created now algorithms that you can know what's happening at your home, what actual appliances are turning on just by looking at just the metered value coming into the house. It just understands the AI today is looking at it and it has the signatures that recognizes, oh, I could tell, it's pretty easy to know when your AC does, but it's interesting that it knows when your freezer's going into a defrost type sequence. It has those abilities. It's pretty powerful. And you have the ability now to potentially control with smart appliances what you do on this side. This actually is a smart inverter. So this house actually has rooftop solar. We have a lot of that in Austin. And then we are now putting in smart inverters that actually can provide other type of things than just taking that DC power off of solar panel and turning it AC. Now we could actually maybe inject VARs into the system. We could do voltage support. We could do different types of things where we can control how much the export is into the system. So this is a unique device that is changing how we're even doing that. I won't get into this. This is a real interesting meter collar, or how we actually are providing a quick connect. This is a Nissan Leaf that has the ability to discharge its battery onto the grid, and that's what this device causes. I will tell you, just talking about the maturity curve for just a moment, is the charger here actually costs more than the Nissan Leaf. So we haven't quite reached the cost price point yet. But the point is that's changing, right? I mean, think about what it's like that you have your own battery supply sitting in your own garage potentially. I used to drive a Nissan Leaf, so I would take that. I think there's a lot of value. We are moving toward this, and I'll talk for a moment about that. And I can see how I typically run out of time. Let me ask you this real quick. Do everybody know what SAIDI, KD, those things mean? That's what utilities love this stuff. We compare ourselves. We talk about SAIDI, SAIFI, and KD. These are basically reliability indices. I won't spend the time to tell you what they define, but the reality is a customer does not care when this is what you're experiencing, right? So this is the New York Manhattan power outage this last summer. Everybody's kind of heard about that story. And they don't care how good your SAIDI, KD, and SAIFI are. In fact, the reality is, because this is downtown New York, Con Ed, I've actually been here, I've seen this utility, I know what they do. They have extremely high reliability because it is an underground system. All this stuff's underground. But when they do have a problem, and they don't care what that means. So the reality is, this has been something I think utilities have had to grab a little bit further hold of, is we need to probably quit talking about SAIDI, KD, SAIFI, all those numbers, and really ultimately talk about the experience they're having, and understand that in the case of Austin Energy, who has extremely high reliability, we've got some customers that are experiencing multiple outages because on their line there's a lot of vegetation and the line fuse keeps melting once every month or two. That's something we have to change, and it doesn't matter how much we talk about how reliable we are. This is something else that I thought I'd share with you. So this is Austin Energy responding to 2 years ago Hurricane Irma, and so if you remember 2 years ago we had 3 major hurricanes hit the U.S. and in Puerto Rico, it's horrible situation. What happened here, the unique thing, and this is why I talk a little bit of, switch from reliability to resiliency. Y'all know what the difference is? So, resiliency is not necessary. Reliable systems can be very resilient, but but resiliency is how quickly you can come back and restore from certain events. What they did is they contacted me prior to the storm to pre-stage people. So they said, hey, can you provide linemen? Very often what utilities do, they call a mutual aid, mutual assistance call. We provide resources to help them restore, because when they have a service territory about 500,000 customers like us, they saw 75% of their customers with a sustained power outage. So it takes a lot of people to bring power back. We were called beforehand. In fact, I remember the guy talking to the guy on the other phone, and he said, I said, you want us to come before the hurricane hits? And he said, yes. And I said, I'm not putting my people in the eye of the hurricane. He said, no, we'll set you outside of the area, put you in a safe place, but when the storm, after it hits, we're going to want to mobilize. So we did. And this is changing the paradigm. I guess my point being is that customer experience is changed where it used to be a storm would happen, hurricane would hit, and people spent weeks waiting for their power to be restored. And within 5 days, every single one of those 75% of their 500,000 customers had their power restored. And that was because of people like ourselves being staged and ready. This is part of how the world's changing. People's expectations are different than what they used to be. So reliability in the modern grid, just talking about, for me, when I was at the semiconductor firm, semiconductor company, AMD, to me, it's a three-legged stool. I mean, the reality is you're ultimately optimizing that supply, that distribution, and the point of use. And so how that looks in that far right over here is, we had a utility supply, and we spent a lot of time beating on the utility. It's funny how I used to, now I wear the other side of the hat, but I used to beat on Austin Energy about the reliability of their service. But there's a whole facility side of this, and I use the word facilities. There's the electric side, but if we think about the customer ultimately being the process, there's other things than just the electrical supply, right? So there's processed gases, there's ultra-pure water, there's exhaust systems, there's environmental control. And quite honestly, reliability and resiliency looks different based on the system you're talking about. Because quite honestly, I can lose my air conditioner in my factory for a short bit of time and I'm not going to affect temperature enough to matter, right? So I don't need it to be 100%, but I certainly need it to restore relatively quickly, maybe within 5 minutes of an event. So the thing, when I'm looking at ultimately what we were trying to solve, and factories, by the way, run anywhere from 30 to 150 megawatts of power. Some of you have facilities that are in that in excess. You have to solve these problems really using this optimization. So it's ultimately it'd be great if I had a 150 megawatt UPS that just never lost power. That'd be great. But that's kind of an unreasonable, and unrealistic thing to obtain. So if I'm able to optimize what I do from the electric supply, but then also doing work in the distribution system and then addressing the point of use, and it's a constant optimization curve, then I could actually achieve what we're ultimately trying to do, which at Austin Energy or at AMD was to produce semiconductor wafers, microchips, right? So that was the ultimate output. The question is how to get there involved a real optimization problem. So today's distribution system has changed, and I am looking at the time, so I'm going to go through this one quickly. This is what I say a little bit of what the future is looking like. So here in Texas, and people you may not know, but I mean Texas, if it were a nation, would be the 5th largest wind producer in the world. So we have a tremendous amount of West Texas wind. That's great. In fact, there are times when over half of the load served by ERCOT, the Electric Reliability Council of Texas, is served from wind power. And those happen to be on good, cold days where there's a lot of West Texas wind in the morning. But it's a valuable thing. What we're seeing now is a whole lot of solar is being co-located with a lot of these wind farms. So there's a large amount of solar going in. And I think the future is going to include some level of battery storage. And we're starting to see some of our power agreements, including the option to add battery storage into the system. But quite honestly, we have to get this power to the people that use it. And I always joke about this. West Texas, if you've ever been out there, there's like 2 people that live there, right? So the reality is we got to get that over into the I-35 corridor, the Dallas, Austin, San Antonio, Houston area. That's where all the people really live. So we're going to continue to have a bulk electric system. The grid's not going away. Sometimes there was a point where people talked about that, but it's not. It's a significant part. But we are starting to see a resurgence in some degree of microgrids. Jury's still out with what I think is really going to be a value proposition there. But for many of you, you may have generation at your own plant. You may have cogeneration at your own plant. So in a sense, what people call microgrids we've been doing for years and years. Military campuses. This campus itself is backed up by Austin Energy, but it's currently being served by a cogeneration plant. So it's a microgrid, this 40 acres of UT. But then this is kind of interesting. Anybody seen this? This is off of Tesla's website. So this is the Tesla house. This actually is these are all the roofing materials made out of this special solar roofing material. So of course you've got this power wall, battery storage, and then that's the $85,000 Model S, right? And that's the whole package deal. So this effectively is a little what is being often termed now as a nanogrid. So people have the ability where they could kind of operate off grid. But the reality is it's not a very good economical model for people to work off, because what happens a lot of times, this person's working all day, it's a nice cold sunny day, and their excess power is they've long stored it in that power wall. The ability for them to export that into the grid is a very valuable asset for them. Problem is that connection, that interconnection to the electric utility costs money. And so poles, wires, and transformers are still a necessary part of what we do, but we traditionally have been billing customers on a volumetric rate, not on an actual fixed cost for what it costs to put the installation. So these are some of the changes that have to be addressed moving forward. All right, so this is a case study from my past. I thought I would share it with you. So when I worked 2 years in Germany with AMD, Advanced Micro Devices. One of the interesting things in Germany is very high price of electricity. And this is, by the way, 20 years ago, so I want to get it some context. We were building a microchip factory there, and the high price of electricity, basically decent reliability, but they did a lot of underground cable, a lot of construction, so they had a lot of vulnerability with some of the service, and they had very low natural gas prices. Same time, microchip factories they're tremendous thermal hosts. They have a lot of needs, in regard to both hot water, cold water, chilled steam, those type of things. So bottom line is, a cogeneration plant made a tremendous amount of sense there, because we had I will tell you, I guess going back for just a moment, when I met with the general manager of Hamburg Electric, who was responsible for the Dresden area, he told me, listen, don't worry, our power is extremely reliable. We never have a problem and all. 2 weeks later, a guy left grounds on a transmission line, and we had a massive power outage due to this and all. So that was very timely. I said, okay, these things don't happen in Germany, is what he said. But they do, and people do make mistakes, and human error is a reality of our world. And so long story short is that was a great impetus for us to go in and put in a very unique cogeneration plant, because one thing that we did need to address is what happens when you actually lose a generating unit. In fact, we had looked at this. There were other semiconductor factories that had some cogeneration, but the problem was the plants they would periodically lose generation. A generator would trip offline, and that they actually would have greater unreliability than what would be if they would have been fed from the utility. So what we ended up doing was we ended up installing a flywheel system that basically would handle those momentary situations where a generator would trip offline, inject power until we could start another generator. So it was basically a buffer. It also handled when we had different things occur on the load side. So if we had equipment suddenly drop off and you had overgeneration at that point, this had the ability to absorb power into the system. And it also handled when the utility had a fault. So when the utility ended up having a fault, which for semiconductor industry, maybe some of you the same situation is a voltage sag can cost you $500,000 in lost scrap product, right? Loss of the process. So the ability to then basically provide voltage support to the bus serving AMD happened through this same flywheel device and all. So this was a really unique system. The other thing that I was able to do on this was probably the most amazing thing, and what really caused us to go forward is the power company, in partnership with a developer, was willing to give us contractual guarantees. So they were willing to basically state, if we do not meet the criteria and the tolerances of their supply, then we will pay you money. And so this system, as far as I know, is probably the most reliable generation system serving a semiconductor factory in the world. In fact, when they built the next factory, and I wasn't there at that time, they basically doubled the plant and redid this. This will be my last story, and it's kind of interesting. It was just several months ago. A call you don't like to have is when your general manager comes down to your office. She's on the cell phone, and she basically states, the hospital has lost power and all. And I'll leave this as a nameless hospital here in Austin, and I calmly listened to the customer and said, all right, we'll check what's going on. Certainly my crews were already dispatched. They were already moving there, but I headed there as well. When I got there, and this is kind of the interesting thing that I'm trying to show. These are my guys. They're basically looking in, right now we're dissecting and troubleshooting what actually occurred. What did happen is we blew 2 fuses, bayonet fuses, in this pad mount transformer. This particular hospital had 2 pad mount transformers serving them. This is the main tie main arrangement on their side, and I took a picture of it, and I also have not, to keep the anonymity, I've only shown you a couple of pictures here, but I took a picture of it because the first thing I did when I looked at it, I said, well, why don't we go ahead and close the tie? And the first thing he said is no, we can't close the tie. And I said, why? He said, well, we've long exceeded the capacity of the switchgear, so it won't serve our load. I thought, okay, well, that's not so good and all. And so then, so we didn't know what happened. We didn't know why those bayonet fuses blew. So the hospital administrator, I met with the CEO of the hospital that night. We're all up into a boardroom. I got the chief of surgeons sitting next to me, facility people. They've got a lawyer there. I didn't have my lawyer. That needed to we're always supposed to be represented. But we're having this conversation, and they, and they look to me, so I'm all sweaty, and they looked at me and they say, okay, what happened? I said, well, we don't know. We don't know what happened. We definitely blew 2 bayonet fuses here. And I said, there's really 3 possibilities, and we've got to figure out what those are. The first possibility is we got a problem with our transformer, and we're dissecting that. We're trying to see if that's the case. Second problem is there could be a problem really with the cable and the switchgear between that transformer and your service. But the third problem is there's something going on your side. Either your load has increased, or you have some piece of equipment that's faulty, something cycling, something of that nature. Well, the facility people, they chimed in and they said, no, we haven't increased load in 10 years. There's no way, that. And I said, listen, I'm not pointing the finger. I'm really not. I'm just wanting to point out that we've got this thing that we want to dissect here and try to understand, because quite honestly, the struggle here, and the guy asked me, he said, well, how long would it take you to replace your transformer? I said, well, we could probably replace it in about an hour. They said, well, let's just do that. And I said, and then before I could even speak, the CEO of the hospital said, but if it's not the transformer, then that won't solve the problem. I said, bingo, that's good. All right, very quick to learn, that's a good thing. So I ended up that night, I told my folks, I said, let's put a power quality monitor on this. It needs to be on there tonight and all. So we restored power, put a power quality monitor on there. We're measuring it. That next morning, 10 o'clock, I get a call and said, we're already at capacity on that transformer, and we haven't even hit the summer. We have not even turned on. Then I'm having this conversation with the facility people at the hospital, and they said, well, yeah, we did add a new glycol chiller and a cooling tower. And, well, yeah, we did this expansion of the wing. So it's an interesting story, right? Because what you're faced with here is I don't want to embarrass the guy, right? I mean, it said, well, okay, we know why the bayonet fuses blew. And we don't know exactly why you didn't contact us and say, hey, we're going to be increasing our load. Could you do something with our service? But what I realized in this process is who's responsible for reliability? Yeah, it is everyone, and that's so. As a utility person, I'm saying, listen, we're here to help, and I'm not just focused on the fact that, oh, good, it wasn't us. I'm glad it wasn't the utility, right? It's like, no, the reality is this hospital serves a lot of critical patients, of which they had, with this power outage, if it would have gone for another 30 minutes, they would have evacuated the hospital, which involved a bunch of the neonatal unit. This stuff's serious stuff, right? I mean, it's important. Reliability matters. And so, quite honestly, I'm no longer worried about who to point the finger at. I'm very much interested in how do we solve your problem. So I spent a lot of time with those facility people and said, listen, let's talk about how we got here, but then recognizing that the people that are responsible for reliability, yeah, those facility people, they are, but they don't know especially at a hospital. It's real interesting is I think a lot of them are thrown into an area that's a failure, because this situation's been this way for 20 years. And I didn't show you pictures of really the disrepair that this electric system was in. So they needed much more support, and that was where we started to think about the people that are in the supply chain, some of the equipment suppliers, but especially the contractors and consultants they had hired. Yes, sir.
Wouldn't you, as the utility, know that their load had increased? If you asked them if their load had increased, but through their metering,
Yeah.
wouldn't you know that their load had increased X amount in this period of time? Wouldn't that be something that
Well, that's a great point, and I think so. Let me once again, I'm not pointing the finger, right? So no, it's an excellent point, and I'm glad you brought it up because that was one of the things that we walked away with was recognizing that this was one of the few places where we had not upgraded the metering, and so we actually did not have good interval data on that. Almost all our other metering, and it still was a smart meter, but it actually had not ability to give us interval data, so we actually did not have good information on what their actual load was. Very good point. The other point is when you blow a bayonet fuse, which what I learned, and I didn't share this with you, is we had blown another bayonet fuse 2 weeks prior. So I admit, back to this aspect, when you blow, when you melt the bayonet fuse, I asked my folks, I said, so what did we think it was? Well, we just assumed we had storms. We just assumed that it was a weak fuse. Sometimes that happens. This is one of the challenging parts, is sometimes that is a reality, but when you're feeding a hospital, it's like, well, why don't we take that one back? So that we would end up doing what you're actually suggesting is well, maybe we need to do a little bit more analysis to understand why we blew the fuse the first time. But it's an interesting reality because mentioned before when I told you that the utilities facility, in a sense, spans thousands of miles and all. And so that's our responsibility, hundreds, thousands of miles. That's our responsibility. And so at this point, you blow fuses, you don't necessarily do a thorough investigation each time. But what I changed, I said is, and this is interesting, I've been the VP for 5 years, I said, yeah, we got to change this. If we're serving a critical load and we blow a fuse, we're going to do an investigation. You launch that thing to engineering, yeah, go refuse it. I'm not saying don't get them back up, but by golly, let's figure out why that fuse blew, right? It's a great question. I know, yes, sir. Yeah. 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 It's a great point. I think my closing statement here, and I think is that back to this aspect of what we're ultimately about, and when I think about it, and I'm going to just, because obviously I've totally blown the time here, why Austin Energy ultimately exists and what we do in electric service delivery, the transmission distribution arm, is I ask them, hey, why do we exist? My response I initially got from my team was, we keep the lights on. No, that's what we do. Why do we do it, right? Why we do it is we enrich the lives of our customers and our communities. In fact, customers, I already stated, they don't care what your Sadie Katie is, right? What they ultimately care about is that I'm able to go do the things that enrich my lives, that help my community, that help my business, whatever that looks like. That's what matters. So quite honestly, that's the experience that we're trying to deliver. And that focus really changes the perspective. And quite honestly, it changed. I didn't really go much on this story, and I appreciate your comment because at the semiconductor industry, the first time I ever stood up and spoke to people and all, which God help them, God help you as well, but when I stood up and spoke to people, it was at a semiconductor forum. We had semiconductor companies throughout the country there, and I got up as a facility guy and started talking about that whole that basically three-legged stool paradigm of what it looks like, and recognizing that my job was to go across the fab walls into the process equipment and help solve their problems. I had several semiconductor people come up to me and say, can we hire you? We have not heard a facility guy say that. Now, I'm not saying this to pat my own back, the point is that my job wasn't just to say, hey, our power's good, and then, let the fab take care of it, right? My job was to help solve their problems because we had to produce wafers, right? And I know many of you, that's their whole mindset, but the whole thing, it changes the paradigm in regard to how we're dealing with things when our mindset is understanding why we really do what we're doing. What is that we're delivering? And that's a significant part about this. And then that changes my conversation with this hospital. This hospital, be honest with you, they did not like to see me retire. But I'm not the only person, by the way. I mean, I've got a team of people behind me that this is what they get as well. But they knew, because they knew, listen, I'm not going to embarrass you in front of the CEO, but let's go talk about how we're going to solve these problems. I know it's on the other side of the meter, which, by the way, at times we're not supposed to work on the other side of the meter, but man, we got to make sure you're not evacuating a neonatal facility. So that's it. I apologize because I cannot believe how badly I predict time. My wife gives me this other thing all the time. So.